Okay, now what I want to talk about is multiplying polynomials. Um, so we want to look at some of the just basic multiplying of polynomials. Let's review what if we had 2x plus 3 times x minus 4. Now, when we multiply that out, your teachers may have taught you FOIL, but really all you're doing is distributive property twice. You're going to be distributing the 2x to each of these terms, and then you're going to distribute the 3 to each term. So you may have seen your teachers drawing these little pictures where they're showing your distribution. I also have shown my students to use what I call a multiplication box to keep yourself organized. A lot of people like this. You can use it if you like. 2x plus 3, and then the other one was x minus 4. It's kind of like what you would use in science or whatever, but it's a multiplication box. 2x times x gives me 2x squared. 2x times negative 4 gives me a negative 8x. 3 times x is 3x. And then 3 times negative 4 is going to be negative 12. Now the neat thing about using the multiplication box is we can see our like terms very easily. Here's my like terms. So when I come out with the answer, I have 2x squared, negative 8x plus 3x gives me negative 5x, and then minus 12. Now there's some that are very special patterns that I want us to look at. One special pattern is the pattern, it's called the sum and difference. That's when we would have, let's see, a plus b times a minus b. Now, if we use this to multiply it out, a plus b, a minus b, a times a is a squared, a times negative b is going to be negative, and usually in math we write it in alphabetical order. B times a is going to be ab. B times negative b is going to be negative b squared. The nice thing about when you have a sum and difference is when we have this sum and difference, when I'm being added, when I'm being subtracted, and everything else the same, the middle terms always undo each other. They add to be 0, so that always disappears, and we'll be left with the first term squared minus the second term squared. This is called the difference of two squares. Nice, huh? So if you start to notice those patterns, you can do them a lot faster. So number 3, let's say we had 2x plus 3 times 2x minus 3. If you recognize that that's the difference of that's a sum and difference, then you know you would not have a middle term. It would just be the 2x times the 2x, which gives me 4x squared, minus the 3 times the 3, which is the 9. Very nice shortcut. Now another shortcut. What if we had, and actually this time I'm going to use the example first. I'm just going to keep mixing it up. Let's see if we can figure out the pattern here. Y plus 3 squared. Now, when we square something, remember that means I'm going to multiply it by itself. So when I go to multiply them together, I'd have y plus 3 and y plus 3, y squared, 3y, and 9. My like terms are here, and ended up with y squared plus 6y plus 9. Now some of these easier ones, you may not have to go through all this, because when you distribute, you know you're going to have 3y plus 3y gives you 6y. Let's see what happens if I had x minus 2 squared. Remember that's going to be x minus 2 times x minus 2. Maybe we don't need the box for this one. X times x gives me x squared. I'd have a negative 2x and another negative 2x. That's going to give me negative 4x. Negative 2 times negative 2 is going to give me a positive 4. Now the pattern for here, for when we have perfect squares, this is another one of these patterns that I really would like for you to know. Here's that first pattern that we looked at. This pattern is this perfect square pattern. And it is so useful. The perfect square pattern says that if I have a plus b squared, watch what ends up happening. That is 2 times, we get a squared plus 2 times these multiplied together, plus the last number squared. Now if it had been a minus in there, the only thing that would have changed is that we would have minus 2ab plus b squared. So let's look at an example of that. What if I had (2x minus 5 squared). So the pattern says I'd have the first thing squared, which is 4x squared, minus 2 times these multiplied together. Well, if I multiply those together, I would get negative 10x. But double that, that's negative 20x. Nice. Then I have negative 5 squared, which is positive 25.